Hi guys, this tutorial concerns both homework assignments that I've given you titled Manipulating Decimals Worksheet A as well as B. A is a little bit simpler than B and a little bit shorter, but they deal with the same concepts. If you look at the worksheet beginning with the table, one thing that I'll ask you to remember is percent is the same thing as saying the phrase out of 100. So when we discuss a percentage, we're talking about a certain quantity out of 100. This is important because you'll notice that I listed a couple of examples here, starting with 37%. Well, if these two phrases mean the same thing, then I know that 37% is the same as saying 37 out of 100, which is expressed as a fraction this way. Now, thinking about this as a fraction, another way you can interpret a fraction is that it's a division problem. Thinking of the numerator being divided by the denominator, and anybody with a calculator punching in 37 divided by 100 is going to determine that it's 0.37, and also reading this, it's not a shocker because that says the same thing as 37 hundredths. The important thing here is this: if we're going to divide by 100, an interesting pattern develops. Every time you divide a number by 100, see if you can determine this, but the decimal from the percentage over to the decimal representation itself has actually just picked itself up and moved. And the interesting thing here is when you divide by 100, you're actually shifting the decimal 2 places to the left. Now, using this information, it's very helpful because I sometimes get the percentages that I want you to express as a decimal that actually have a decimal within the percentage. And if we're just bumping the decimal twice to the left, then I merely need to go like this. This is due to the fact that 26.2% is the same thing as 26.2 out of 100, which expressed as a decimal would then look like this. One thing that we could probably get used to is every time we look at a decimal, just to start thinking about these first two places as a percentage, because we deal with these so often. Okay, now moving on to the bottom half of the worksheet, we're trying to catch on to an interesting pattern here. And the pattern is this: finding 10% of a specific number and using that to help us find a different percentage, but of the same number. Okay, now I'm going to go through this 10% of 2520 example with you, and let's do it through the context of sales tax. If somebody were purchasing something for $25.20, that being the total, and there was a tax of 10% tax, of course we've learned that 10% tax means that for every dollar we spend, we have to add on an extra, in this case, a dime. So in other words, how could we find out the tax? We could take however many dollars that we are spending times a dime for each dollar to determine the tax. Okay, and remember, 10%, expressing this as a dime, would mean that, yes, we have to slide that decimal 2 places to the left, and a dime is written this way as a dollar amount, and that's important. Okay, so now going through the multiplication here, I'm actually going to take the number of dollars we spent, if we want to talk about it that way, times a dime per dollar, and I'm actually going to opt to put 2520 on top. Now, there are a couple reasons why I'm doing this, but one big reason is this. You just get used to putting the longer numbers on top. It generally reduces the amount of work that you have to do, unless the longer number contained a lot of zeros. Now I look at this, and this contains a lot of ones and zeros, and this is where this pattern emerges or develops. Multiplying by this first zero, you notice that we get an entire array of 4 zeros, because anything times 0 is 0. Now, I'm done with this 0, but before we move on to the 1, we do need to be building in a place value right there in the 1 spot. Or just putting in a 0, and I tend to put a box around them. But remember, anything times 1 is itself. And here's where the pattern kicks in. I can basically just copy and paste these numbers right here, straight down. And since all we have remaining to multiply with is a 0, we can decide to be done at this point. Now adding this, it's not a surprise, it's not a surprise that we get the same 4 digits back that we began with. But the interesting thing here is you may notice that there's another 0. Now, one thing that we've forgotten to do thus far is to put the decimal in the correct spot. Now, remember, what we're counting up is the number of digits that occurred on the right-hand side of a decimal, or the fraction side of a decimal, up here with our 2 factors. And this occurred 4 times. There were 4 digits to the right of a decimal. So what we'll do is we'll adjust the decimal accordingly. And here's what I really want to notice. We got 2.52. Now, comparing the original quantity to the new quantity, 2.52, I usually ask people, hey, what changed from here to here? And one answer I typically get is, well, we lost a 0. But you know what? I can solve that problem. I can put that 0 back in and not technically change the value of this number. However, when you look at these side by side, you notice there's a difference. The difference is this. The decimal has moved itself from the right to the left one spot. Excuse me, my phone's ringing. Anyway, the neat thing about finding 10% of a number anytime is that you can just take the original quantity and shift that decimal once to the left. Here, I'll show you this. What if I gave you a new number? $17.60. Now this is 100% of what we're starting with. Look, if I want to find 10%, 10% is merely equal to just going like that. 10% must be $1.76. Okay, because this is 1/10 the size of the original. 10% is 1/10 the size of 100% of what we started with. The neat thing about it is this. Finding 10% of a number no longer becomes a multiplication problem, but a mental problem in which we just shift the decimal once to the left. Now, why am I getting so excited about this? Okay, well, I'm getting excited because we're dealing with the same quantity down here, but I wanted to find 20%. And some of you might be thinking already, well, hey, how does 20% compare to 10%? Of course, it's double the size. So I guess logically, my question would be this. If 20% is double the size of 10%, instead of having to go through and find 20%, can't we just take 10%, which is what we've already found was $2.52, and just double it? And the answer to that question is absolutely, let's do it. So here's what I've already established. Mentally, I even can make note of this, but 10%, and I am going to write this down because I want to see this, 10% is equal to $2.52. Now, I wanted to deal with this number because it's kind of easy to double, but if I'm looking for 20%, this is very similar to those problems that I give you where you have two fractions and I don't tell you one part of it. Okay? So, if I know that 20% is twice 10%, I get in this habit of drawing in an arrow and saying, yes, I multiplied that by 2. Now, one term you haven't heard me use a lot of yet, but you're going to get sick of very, very soon is scale factor. A scale factor is a number that tells you how many times bigger or smaller one thing is than another. And in this case, 20% is 2 times bigger than 10. So we're going to refer to this number as a scale factor. But in order to maintain proportionality, which is another big word you don't have to worry about, but equality, the same type of balance. If we double 10% into 20%, we must double this quantity into our new 20% quantity. So, just like with fractions, what you do to one side, you have to do to the other. And thinking about this sort of mentally, well, if I doubled $2.50, that'd be $5. And if I doubled 2 cents, that'd be 4 cents. So what we wind up with is this. $5.04. The interesting thing about this is, hey, now that I know this trick of finding 10%, think about how easy it would be to find 5%. Just by taking 10% and cutting it in half. What if I knew 10% I was looking for 50%? Okay, shift the decimal once to the left, find 10%, and then take it times 5. Inflate it by a scale factor of 5. Okay, we could even find 1%, get this, by finding 10%, shifting that decimal once to the left, and then finding 10% of 10%. In effect, if you ever wanted to find 1% of something, you could technically just shift the decimal twice to the left. Okay? Now using this new tool, finding 10% of a number by just shifting mentally that decimal to the left one spot, and of course writing it down somewhere, not just assuming that I know that you did that, but doing that, that's going to help us find all sorts of different percentages. Good luck to you.